There are no blue tigers, no blue bats, no blue squirrels, or blue dogs. Even blue whales aren't that blue. They appear blue underwater due to the way light scatters in the ocean, but their actual skin is more of a grayish blue. Animals come in pretty much every color, but blue seems to be the rarest. It's almost like nature has a special rule against it. What's cool though is when we do find a blue animal, they're awesome looking. Nature doesn't do halfway with blue. When it goes blue, it goes all out. To understand why this is, we're gonna journey through evolution, chemistry, and some very cool physics. It's a fascinating intersection of different scientific fields. But first we're gonna need to understand why animals are any color at all. And to do that we need to go look at some butterflies, because butterflies are awesome. And they hold many secrets about color. And if you don't think so, you're wrong. This is Bob Robbins. He's curator of Lepidoptera at the National Museum of Natural History in Washington, D.C. Butterflies are awesome. Make no mistake about it. Their beauty is not just skin deep, it's a marvel of natural engineering. They're a group of moths that evolved to be active during the day. And if you're active during the day, you have an advantage. You can use light to communicate. This is a game changer in the animal kingdom. You probably realize this, but out of all insects, butterflies display the brightest and most detailed patterns. Their wings are like canvases painted by nature. And there's a good reason for that. The colors in butterfly wings deliver messages like, I'm toxic, or I'm a male and this is my territory, or even, I'm a female ready to mate. But not all butterfly colors are created equal. Some are more vibrant and noticeable than others. If we zoom way in on a butterfly wing, we see the colors come from tiny scales. These scales are like tiny tiles in a grand mosaic. It's actually how moths and butterflies get their scientific name. Oranges, reds, yellows, browns. Those scales all contain pigments which are like natural dyes. Organic molecules that absorb every color except what we see. It's a fascinating process of selective absorption. Black scales absorb all colors. They are like tiny black holes on the wings. Animals from butterflies to birds to you and me don't make these pigments from scratch. They're made from ingredients in our diet. It's like a natural chemistry set inside our bodies. You might know this thanks to flamingos. They're born gray but turn pink thanks to pigments called carotenoids in crustaceans they eat. It's a transformation that happens over time, so when it comes to these colors, you are what you eat, literally. But not so for blue. Blue is different, it's a whole different ballgame. If you move the camera, you can see that the color changes as you move the camera. It's like magic. It does, it's like a hologram thing. A natural hologram. This is because there's no blue pigment in these butterflies. Wait, so they're blue, but they're not really blue? That's correct, yes. It's an optical illusion created by nature. You're lying to me, butterflies. Or maybe just playing a clever trick. These are blue morpho butterflies, maybe the prettiest butterflies of all. Their blue is mesmerizing. I mean, they did make it the butterfly emoji. That's how iconic they are. The blue color isn't from a pigment, the blue comes from the shape of the wing scale itself. A marvel of structural engineering. And when I learned how this works, it kind of blew my mind. It's like discovering a hidden secret of nature. If we zoom way in on a blue wing scale, we see these little ridges. They look like tiny ridges on a mountain range. If we slice across the scale and look closer, we see those ridges are shaped like tiny Christmas trees. It's a festive design by nature. The arrangement of the branches is what gives morpho wings their blue color. It's all about the geometry. When light comes in, some bounces off the top surface, but some light passes into the layer and reflects off the bottom surface. It's a dance of light and structure. For most colors of light, waves reflecting from the top and bottom will be out of phase, they'll be canceled out, and that light is removed. It's a natural filter. But blue light has just the right wavelength. The reflected light waves are in sync, and that color makes it to our eye. It's a perfect harmony of light. This hall of mirrors only lets blue light escape. It's like a magical portal. There's even a pigment at the base that absorbs stray red and green light to make the blue even more pure. It's a fine-tuning mechanism. That's how we get this awesome iridescent blue. It's a dazzling display, the microscopic structure of the wing itself. It's a masterpiece of natural design. All of this happens because of the way light bends when it moves from air into another material. It's a fundamental principle of optics. So if we fill all those tiny gaps with something other than air, like alcohol, the blue disappears. It's like a magic trick. Technically, this changes the index of refraction, but in plain English that means blue light is no longer bent the right way. The magic is broken, the microscopic light filter is broken. Until the alcohol evaporates and the color returns. It's a temporary disappearance. But these butterflies live in the rainforest, a place where it rains a lot. You think they'd lose their color anytime they got wet, right? Well, watch this. Nature has a solution. These wing scales are made of a material that's naturally water resistant. It's like having a built-in raincoat. What about this blue jay feather? Another example of nature's ingenuity. If we look through it, the color completely disappears. No blue pigment. It's another trick of light.